investigate the law of cosines with the ambiguous case today. And the ambiguous case means you're not necessarily guaranteed a triangle. For example, what if this angle here was 40 degrees? What if this side here was 12 and this side here was 10? What could happen is this 10 unit side here could actually swing a variety of ways. It could go 10 that way, or it could go 10 this way, and it could still reach that third side, and you could still maintain an angle and a side length of those dimensions. And so what you have here is the angle side-side postulate. Do you remember learning the angle side-side postulate in geometry? Of course not. We do not have a postulate like that because it doesn't guarantee a triangle. If you have an angle side to side, what could happen is you could get one triangle that is formed. Sometimes you get two triangles that could be formed like this, or sometimes you get 0 triangles that are formed. For example, what if you had a 40, a 12-inch side, and then a 3-inch side, and it just doesn't reach no matter which way you swing it. It's just never going to reach this third side. So angle side-side is not a postulate, and that is called the ambiguous case. Whenever you have this, you need to use the law of cosines. Now you could use the law of sines, except you have to stop, figure out if it's one triangle or two triangles or three triangles, take the supplement of that angle, plug it in, see if it works, do lots and lots of thinking, even though the formula is easier. With the law of cosines, the formula is a little trickier in the beginning, but then all the work is done for you. If there's two answers will appear. If there's one answer will appear. Okay? And that's exactly how we'd like it to happen. So let's take a look at this first triangle right here. We have A, B, C, any old way. A, B, C. Little c is 6. Little a is 7. And the measure of angle C is 29 degrees. Oh, look at that. I'm noticing angle, side, side. Okay, this is the angle, side, side case, which means we should use the law of cosines. Maybe I should stop writing that word all over my paper. Okay, since the angle determines how the law of cosines starts, we're going to have to start with the 6 squared equals the 7 squared plus the other side, which is little b squared, minus 2 times one of each of these, a 7 and a b, and the cosine of angle 29 degrees. So how are we going to solve this? I'm noticing that there's b squared and there's a b. This is a quadratic equation. We're going to put this in descending order, and I'm going to put everything to the right. B squared. This is minus 14. Let's put cosine of 29 degrees first, and then the b. So that's the coefficient in front of b. And then what's 7 squared minus 6 squared? Okay, 13. All right. Now the best way that I found to solve this nice quadratic equation is with the quadratic formula. So please turn your calculator on. Let's just ignore that warning. We're going to go to the program button right there, and we're going to use the quadratic formula program. Okay? Now, we're going to find the roots, the solutions. If it's ax squared plus bx plus c, which we've done, we've put it in descending order. The a number is a 1, so you type 1, enter. Now it wants to know b. Okay, the coefficient in front of b is negative 14 cosine of 29 degrees. Make sure you're in degree mode before we start all this. And c is 13. Now look at that. There are 2 possible answers, which means this triangle could have a variety of sides for that third length right there. So at this point, what we need to do is split our paper right down the middle, just like this. Okay, and we're going to have to do 2 problems, in fact. So let's draw the triangle again. We have A, B, C. We had 6, we had 7, we had 29 degrees. Now it appears that side B, little b, could be 2 things. B could either be 11.07 or B could be 1.17. Now we're going to have to do two problems. Let's go back up to the top here, and we're going to finish this top triangle. Then we'll do a second triangle. The next one I'm going to go for is angle B. If you're going for angle B, then you're going to have to go across the triangle and start with that side. 11.07 squared equals 6 squared plus 7 squared minus 2, a 6, a 7, and we're going for cosine of angle B. All right, that's all the work you really need to do for that one. It's the angle. Please type that squared, subtract that squared, subtract that squared. Then we're going to divide by all that. When you're doing your work, yada, yada, yada. 2 times 6 times 7. This is negative 84 cosine of B. So all the work that you get there, then you have to divide by negative 84. And then don't forget to cosine inverse your answer. And the measure of angle B is 116.55 degrees. Now, when you're doing the triangle down here, it's pretty much the exact same setup, except instead of, if we go for angle B, instead of starting with 11.07, you're starting with 1.17. So I'm just going to copy this equation here. 1.17 squared equals 6 squared plus 7 squared minus 2 times 6 times 7, which I know is 84, cosine of angle B. So we'll do it again. Measure of angle B is approximately Did you get 5? 5.37 degrees? And then we could just do subtraction to find the measure of angle A. Measure of angle A for each triangle. We have a 29-degree angle, so let's subtract 29. Let's subtract 116.55, and the measure of the angle is 34.45 degrees. And down here with some simple subtraction, measure of angle A is 145.63 degrees. Now what I really want you to do on a test and on your homework is be organized about this. So separating with a line makes it clear that there's two calculations. And I'm going to make a nice organized list of answers. For triangle option number 1, we've got little b number 1. We've got measure of angle B number 1 and measure of angle A number 1. And these three answers go together. Those answers don't get mixed up with these answers. Now these three answers down here, we've got side little b, which was 1.17, measure of angle B. Now this is number 2, measure of A number 2. And these three answers go together in a box. So I'm going to make sure that I'm labeling things very clearly, that that side length and this angle measure all go together. Okay, do not just have answers scattered all around, A and B, because you have to tell me which ones go together to form a triangle. 63 degrees. Okay, let's do another ambiguous case triangle here. Let's draw the triangle ABC. Little a is 6, little b is 2, measure of angle A is 32 degrees. So starting today, you must stop and you must look at every single problem you're about to do and determine which postulate it is. If it's angle side side, you must do the law of cosines. Angle side side. Angle side side, you must do the law of cosines. So since 32 is the only angle we have, we're going to have to use that one. 2 squared equals 6 squared plus, we need to use little c squared minus 2 times 6 times c times the cosine of 32 degrees. Okay, we're going to go ahead and put this in descending order. Since it's a quadratic, that's negative 12 times the cosine of 32 degrees c. And 6 squared minus 2 squared is going to be positive 32. Okay, let's use our quadratic formula program to solve this quadratic. Program, quad formula, here we go. A is a 1. B is negative 12 times the cosine of 32 degrees, and C is 32. Ooh, non-real answer. Non-real answer. So what does that mean? That means this quadratic equation right here has no solution. So what does that mean for our triangle? It means there are no triangles formed. That is not a triangle. Actually, if I draw this picture a little bit better, it would probably look something like this. 32 degrees, and if this side is 6, and then this side is a measly little 2, he's not going to reach. That would be why. Okay? The law of cosines is the best one to use because if there's one answer, you'll get one answer. If there's two, you'll get two. If there's none, you'll just get none. Okay, let's take a look at some word problems here when we apply some law of cosine stuff. So find the lengths of the diagonals. It would have been really helpful had I told you that this side right here is 8 and this side here was 10. Okay, I think those were just given in the problem. So I know from parallelograms in geometry, opposite sides are congruent and opposite angles are congruent. How about consecutive angles? What are they? Consecutive angles are supplementary. I'm going to draw another parallelogram here because if that little acute angle is 40, this one's going to be 140. And this is 8 and 8 and 10 and 10. Okay, find the lengths of the diagonal. So first, I'm going to go for the short diagonal. Did you know that the small angle, the acute angle, is going to make the short diagonal? I'll call that D1. And that the large obtuse angle is going to make the longer obtuse diagonal. I'll call that one D2. So when I'm looking at this triangle, since I'm going for D1, I've got side angle side. Could I do the law of sines? Is this angle 140 bisected? No, that's not bisected. That's not a property of parallelograms, maybe a square. So we're going to do the law of cosines here. So 40 degrees goes with D1. D1 squared equals 8 squared plus 10 squared minus 2 times the 8 times the 10 times the cosine of 40 degrees. Don't forget to square root your answer. I hope you got 6 point, rounded two places nicely. 4, 4. Okay, and now for the length of the larger diagonal. The reason I drew it separately is so you could just look at one diagonal at a time. Sometimes it's a little tricky to see the diagonals crisscrossing and stuff. So looking at this diagonal, we're going to have to use the angle across from him. Again, law of cosines. So we'll start with D2 squared equals 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of, what's his angle? 140. Okay, another calculation. Everything in your calculator, don't forget to square root it. D2, this is the longer diagonal. 16.93. Okay, here's a cute story. An airplane takes off from carrier B. So this must be the carrier here. And it flies in a straight line for 8 kilometers. Okay, so there's the plane. airplane right there. At that instant, an observer on destroyer C, so here's the destroyer, located 12 kilometers from the carrier. He notices that the angle determined by carrier, destroyer, and plane is 37 degrees. How far is the plane from the destroyer? Plane from destroyer. Okay, so they want us to find B. Okay, remember, starting now, you must observe every triangle you work with and determine if it's the ambiguous case. The information given is angle, side, side. Angle, side, side. That is definitely the ambiguous case, so we must use the law of cosines. Law of cosines says you start with the angle, and that goes with side 8. Okay, so we're going to have to do 8 squared equals 12 squared plus b squared. Okay, subtract 2, one of each of them, a 12 and a b and a cosine of angle 37 degrees. Let's go ahead and get this put in descending order. B squared, that's going to be minus 24 cosine of 37 degrees b. And what's 12 squared minus 8 squared? 80. Okay, so please use your quadratic formula program to determine the length of B, how far the airplane is from the destroyer. Oh, 2 answers? Okay, so one of the options is 13.03. How about some units? Kilometers. Or the airplane is only 6.14 kilometers. Well, that's kind of tricky. You can't be out in battle and not have an exact answer. That's because you were given angle, side, side information. So what does that mean? The plane could have flown this way, or the plane could have flown this way, 8 kilometers, still maintaining the 8, the 12, and the angle, but been a lot closer to the destroyer. If you have angle side, side, please use law of cosines. And once you start with law of cosines, you must continue with law of cosines. Let's put that note right here. This is a very important note. Once you start with law of cosines, okay, continue with it. Continue with it. Okay, maybe I'll get a chance to show you in class one day why that's very important. If you start with law of cosines, you find something, and then you switch to law of sines, you might not notice that you've then chosen an angle side side, which is the ambiguous case, which means you might get 2 answers. Then you have to figure out which is the right answer and the wrong answer for that case, and that's just a pile of mess. If you start with law of cosines, continue with it. Okay, on a certain automobile, the crankshaft is 3 inches long, and it's connecting to a rod that's 9 inches long. When the angle OPQ is 15 degrees, let's make sure we find OPQ. So that's this angle right here. How far is the piston P from the center of the crankshaft? So they want us to find this distance right here. I'm just going to put a little X on that side. So let's see. We've got an angle. And now we've got the side length and the side length. Here's another angle side side case. When you have this, you must use the law of cosines. So the angle 15 is across from the 3. Let's start there. 3 squared equals 9 squared plus x squared minus 2 times 9 times x times the cosine of 15 degrees. So let's go ahead and get this in descending order. X squared, 2 times 9 is negative 18. The cosine of 15 degrees x. And what's 81 minus 9? 72. Okay, please determine that distance right there. Or are you not getting any answers? It's either 1, 2, or 0. 10.58 inches, or x is approximately 6.80 inches. And this one makes sense to me a lot because as this piston goes in and out, this distance is going to be changing. So at one point it's 15 degrees, and then at another point it's going to be 15 degrees when this cue circles around. You'll get another angle, but the distance won't be as long. Good job.